Welcome back to Hypothesis Testing Done Right, Part 13 of 14. In Part 12, we named the 3 mistakes to never make. Now we close the chapter's content with a warning that Week 1 only previews. The way a search across many tests quietly breaks the single test logic we work so hard to build. The full treatment of corrections comes later in the camp. Here, we want the intuition to stick. Return to Sam, but change one detail. Suppose Sam did not test one rule. Sam tested 20, reversal, momentum, day of week, moon phase, the lot, kept the one with P below 0.05, and reported only that winner. Has Sam found something? Almost certainly not, and here is the arithmetic. If the null is true for a single rule, the probability of a false positive at alpha equals 0.05 is, by construction, 5%. Now suppose all 20 rules are truly worthless, and, for the illustration, their tests are independent. The probability that at least one of them crosses P below 0.05 by pure luck is 1 minus 0.95 raised to the 20th power, which is about 1 minus 0.358, or 0.64. There is a 64% chance, better than a coin flip, that at least one dead rule looks significant, simply because Sam gave luck 20 tries. Test enough worthless ideas, and you are guaranteed a spurious winner. The per-test error rate alpha was never designed to survive being applied dozens of times and then cherry-picked. This is the heart of p-hacking, also called data dredging, running many analyses, many rules, many variable definitions, many subsamples, many control sets, and reporting only the ones that crossed the significance line, as though that single test had stood alone. The reported p-value is then a lie because it ignores the 19 silent attempts behind it. The problem is general. It is sometimes called the garden of forking paths, because even a single analysis involves dozens of small choices, each a hidden test. 2 honest defenses which the camp builds properly later. First, pre-registration. Committing to your hypotheses and analysis before seeing the data removes the ability to fish because the forking paths are nailed down in advance. Second, multiple testing corrections adjust the bar when you run many tests. The crude Bonferroni rule tests each of m hypotheses at alpha divided by m, so the chance of any false positive stays near alpha. More refined approaches control the false discovery rate, the expected fraction of your discoveries that are false, which is usually the more sensible target when screening many candidate signals at once, as in finance and genomics. To summarize Part 13, the false positive rate of a single test does not protect the search across many tests. 20 worthless rules give a 64% chance that at least one looks significant by pure luck, so test enough junk and a spurious winner is guaranteed. That is p-hacking. Running many analyses and reporting only the ones that cross the line, which turns the stated p-value into a lie because it hides the silent attempts behind it. The honest defenses are pre-registration, which nails the analysis down before the data are seen, and multiple testing corrections like Bonferroni and false discovery. Rate control. The takeaway intuition. When you read a paper claiming a trading rule, a risk factor, or a treatment effect, the first question is always, how many things did they try before they found this one? In Part 14, the finale, we step back, see everything we built, and look ahead to the regression engine of Week 2.